Hello. We all know that several proteinaceous enzymes require an additional chemical component called cofactor. Cofactor may be either inorganic ions or complex organic compounds. These complex organic compounds are known as coenzymes. Generally, coenzymes are derived from B vitamins. Such coenzymes are actively involved in the catalytic reactions of enzyme by serving as intermediate carrier of functional group in biochemical reactions. Moreover, deficiency of precursor vitamins of coenzyme leads to certain disease condition. In this lesson, we will discuss about the structure, function and reaction mechanism of coenzyme nicotinamide adenine dinucleotide, nicotinamide adenine dinucleotide phosphate, Flavin mononucleotide, Flavin adenine dinucleotide, Thiamine pyrophosphate, and we will also discuss about the deficiency diseases of Niacin, Riboflavin and Thiamine, the precursor vitamins of these coenzymes. Now, what is coenzyme? We know a number of proteinaceous enzymes require an additional chemical component called cofactor other than their amino acid residues. Such cofactor containing enzyme is known as holoenzyme. The cofactor may be either inorganic ion such as iron, magnesium, manganese or zinc, or a complex organic compound such as nicotinamide adenine dinucleotide, Flavin adenine dinucleotide, Thiamine pyrophosphate, 5'-deoxyadenosine cobalamin, lipoid, biocetin, coenzyme A, pyridoxine phosphate, tetrahydrofolate, etc. This complex organic cofactor is called coenzyme. Usually, coenzyme is actively involved in the catalytic reaction of enzyme by serving as intermediate carrier of functional group in biochemical reactions. Enzymes that use same coenzyme usually perform catalysis by similar mechanism. Generally, such important biomolecule called coenzymes are derived from B vitamins. Now see, coenzyme nicotinamide adenine dinucleotide and nicotinamide adenine dinucleotide phosphate transfer hydride ion, and it is derived from precursor vitamin niacin. Then the coenzyme thiamine pyrophosphate transfer aldehydes, and precursor vitamin is thiamine, that is vitamin B1. Coenzyme Flavin adenine dinucleotide and Flavin mononucleotide transfer electrons and acyl groups. It is derived from Riboflavin, that is vitamin B2. Now, coenzyme nicotinamide adenine dinucleotide and nicotinamide adenine dinucleotide phosphate. The compounds nicotinamide adenine dinucleotide NAD+ and nicotinamide adenine dinucleotide phosphate NAD+ are coenzymes derived from niacin, that is vitamin B3. This is the structure of nicotinamide adenine dinucleotide. This is the nicotinamide adenine dinucleotide phosphate, and this is the precursor vitamin niacin. The only difference of nicotinamide adenine dinucleotide and nicotinamide adenine dinucleotide phosphate is in this carbon atom. In the nicotinamide adenine dinucleotide, it is linked with an OH group, but in the nicotinamide adenine dinucleotide phosphate, the OH group, that is hydroxyl group, is replaced by a phosphate group. Then the function of nicotinamide adenine dinucleotide and nicotinamide adenine dinucleotide phosphate. Nicotinamide adenine dinucleotide and nicotinamide adenine dinucleotide phosphate serve as a coenzyme for different types of enzymes catalyzing the hydrate transfer reactions. Enzyme alcohol dehydrogenase, malate dehydrogenase, homoserine dehydrogenase are examples of nicotinamide adenine dinucleotide containing enzymes. Reaction mechanism. Enzymes with nicotinamide coenzyme carry out hydrate transfer reactions. All the biochemical reactions involving these coenzymes are 2 electron transfer. A general reaction of NAD-dependent dehydrogenase is NAD+ and substrate BH2 reacts to form one molecule of NADH, one proton and product B. This is a reaction catalyzed by enzyme alcohol dehydrogenase. The enzyme converts ethanol into acetaldehyde by following an ordered single displacement mechanism. Alcohol dehydrogenase is a stereospecific enzyme. It removes hydrogen from the pro-R position of ethanol and transfer to the pro-R position of NADH. This reaction proceeds by proton transfer to water, followed by hydride transfer to NAD+. In the active site of alcohol dehydrogenase, serine 48 accepts the proton from the alcohol substrate, and the substrate pro-R hydrogen is poised above the NAD+ ring prior to hydride transfer. Enzymes requiring nicotinamide coenzymes are stereospecific and transfer hydride to either pro-R or pro-S position selectively. Malate dehydrogenase, glyceraldehyde 3-phosphate dehydrogenase are also stereospecific. Deficiency disease of niacin. Deficiency disease of niacin, pellagra characterized by a photosensitive dermatitis, is a deficiency disease of niacin, a precursor vitamin of nicotinamide coenzymes. As the condition progresses, there is a dementia and possibly diarrhea. Untreated pellagra is a fatal. Niacin has been used to treat hyperlipidemia, but excess intake of both niacin and its derivative nicotinamide, that is around 500 mg per day, cause liver damage. Next, coenzyme Flavin mononucleotide and Flavin adenine dinucleotide. Flavin mononucleotide and Flavin adenine dinucleotide are the coenzymes derived from Riboflavin, that is vitamin B2. Flavor proteins which contain tightly bound Flavin mononucleotide or Flavin adenine dinucleotide as prosthetic group participate in 1 or 2 electron transfer reactions. This is a structure of coenzyme Flavin mononucleotide. It is a Flavin adenine dinucleotide, and this is Riboflavin, vitamin B2, the precursor of coenzyme Flavin mononucleotide and Flavin adenine dinucleotide. Then, the function of Flavin mononucleotide and Flavin adenine dinucleotide coenzymes. Flavor proteins containing tightly bound Flavin mononucleotide or Flavin adenine dinucleotide as prosthetic group catalyzes 1 or 2 electron transfer oxidation reduction reactions using these Flavin nucleotide as coenzyme. Enzyme succinate dehydrogenase, acyl-CoA dehydrogenase, thioredoxin reductase are FAD containing flavor proteins. Then the enzyme NADH dehydrogenase, glycolate oxidase are Flavin mononucleotide containing flavor proteins. Now the reaction mechanism. The fused ring structure of Flavin nucleotides known as isoallosagen ring undergoes reversible reduction accepting either 1 or 2 electrons in the form of 1 or 2 hydrogen atoms from a reduced substrate. The fully reduced forms are abbreviated as FADH2 and FMNH2. When a fully oxidized Flavin nucleotide accepts 1 electron, that is 1 hydrogen atom, the semi-quinone form of the isoallosagen ring is produced. These are abbreviated as FADH, a free radical, and FMNH, free radical. In the succinate dehydrogenase reaction, succinate is oxidized to fumarate and FAD is reduced to FADH2 by this Pavlov-protein succinate dehydrogenase enzyme. Deficiency disease of Riboflavin. Riboflavin, a precursor vitamin of Flavin mononucleotide and Flavin adenine dinucleotide coenzymes, is centrally involved in the lipid and carbohydrate metabolism. Its deficiency is widespread but not fatal because there is a very efficient conservation of tissue riboflavin. Deficiency is characterized by callosis, desquamation, and inflammation of the tongue, and a seborrheic dermatitis. Next is the coenzyme thiamine pyrophosphate. Thiamine pyrophosphate TPP is a coenzyme derived from thiamine, that is vitamin B1. This is a structure of thiamine pyrophosphate, and it is thiamine, vitamin B1, the precursor of the coenzyme thiamine pyrophosphate. Function of thiamine pyrophosphate. Thiamine pyrophosphate plays an important role in the chemical rearrangement in which an activated aldehyde group is transferred from one carbon atom to another, as well as it has an important role in cleavage of bonds adjacent to a carbonyl group, such as decarboxylation of alpha keto acids. Pyruvate decarboxylase, which catalyzes the decarboxylation of pyruvate to acetaldehyde, requires a tightly bound coenzyme thiamine pyrophosphate. Then the reaction mechanism. In this reaction of pyruvate decarboxylase enzyme, the functional part of thiamine pyrophosphate, the thiazolium ring, has a relatively acidic proton at carbon number 2. Loss of this proton produces a carbanion, that is, the active species in the thiamine pyrophosphate dependent reactions. The carbanion readily acts to carbonyl groups, and the thiazolium ring is thereby positioned to act as an electron sink that greatly facilitates decarboxylation. Deficiency disease of thiamine. Deficiency of thiamine, precursor vitamin of thiamine pyrophosphate, can result in different syndromes like peripheral neuritis, beriberi, heart failure, etc. So now we can conclude that there are numerous proteinaceous holoenzymes that require an additional chemical component, either inorganic ion or a complex organic compound. Usually such complex organic compound known as coenzyme is actively involved in the catalytic reaction of the enzyme. It serves as an intermediate carrier of functional group. Coenzyme nicotinamide adenine dinucleotide, nicotinamide adenine dinucleotide phosphate transfer hydrogen ions. Flavin mononucleotide, flavin adenine dinucleotide are important for transferring 1 or 2 electrons. And thiamine pyrophosphate transfer aldehyde. As most of the coenzymes, including coenzyme nicotinamide adenine dinucleotide, nicotinamide adenine dinucleotide phosphate, flavin mononucleotide, flavin adenine dinucleotide, and thiamine pyrophosphate are derived from B vitamins. So, deficiency of such precursor vitamins disturbs reactions catalyzed by the coenzyme dependent enzymes and consequently leads to various disease conditions. Thank you.